All right, let's talk about something that drives every athlete, from pro to weekend warrior, absolutely bonkers. Why do some injuries just stick around forever? You think they're gone and then they're back. Well, today we're going to pull back the curtain and uncover a hidden player in your own anatomy that might just be the real reason for all that frustration. You know the feeling, right? That hamstring pull, that calf strain, it just lingers. You do everything you're supposed to. You rest, you rehab, you finally feel like you're 100%, and then the very first time you really push it, bam, it's back. It is such a frustrating cycle. But what if I told you the answer isn't in the muscle you're focusing on, or even the tendon? Okay, let's put a number on that frustration. 63%. Get this. In some studies of elite athletes, that's the potential re-injury rate for certain types of strains. And it all comes down to damage in one specific, and almost always overlooked piece of tissue. So to figure out what it is, first we got to review the basics of how our muscles actually work. To really solve this mystery, we first have to investigate the scene of the crime and look at the usual suspects. And that means we're talking about the muscle tendon unit. This is the fundamental system that creates every single movement you make. So first up, you've got the muscle. Pretty straightforward, right? This is the engine of your body. It's made up of tons and tons of tiny fibers that contract. They literally squeeze together to generate all the force you need to run, jump, you name it. And all that force has to get to your skeleton somehow. Well, that's the tendon's job. Just think of it like a super strong, flexible rope. The muscle engine contracts, the tendon rope pulls on the bone, and poof, you've got movement. It's a really powerful, direct connection. But here's the thing. If it were really just that simple, an engine and a rope, these nagging injuries wouldn't be such a huge mystery. This simple view is, well, it's incomplete. It's missing a really key component. So now it's time to meet the overlooked player in this whole system. It's a structure with a kind of a funny name, but it is absolutely critical to how your muscles function, and that is the aponeurosis. Now, to really get what the aponeurosis is, we need to zoom way in on how a muscle is built. You see, a whole muscle isn't just one big piece of tissue. It's actually made of smaller bundles of fibers, and those are called fascicles. And then those are made up of even smaller individual muscle fibers, the actual cells. It's kind of like a giant fiber optic cable that's made of smaller cables, which are themselves made of tiny little glass threads. So where does our hidden player fit into all this? It's this large, white, sheet-like tissue. The aponeurosis is the super intricate interface where all those individual muscle fibers come to anchor themselves before they connect to that main tendon rope. You can think of it as the crucial bridge between the muscle engine and the tendon. And this quote from a very recent scientific review really gets to the heart of the mystery. It says, the aponeurosis is often conflated with the free tendon rather than being considered an independent structure. In other words, for a long, long time, even in research, scientists and doctors just kind of lumped it in with the tendon. And that is exactly why it's been the hidden player in so many of these recurring injuries. Okay, so we've identified our hidden player, but what makes it so special and, frankly, so vulnerable? This right here is the big aha moment. It all comes down to the totally unique kind of stress that the aponeurosis has to deal with every single time you move. This is the absolute key difference. A tendon, it experiences what's called uniaxial stress. It just gets pulled in one direction, like a rope in a game of tug of war. But the aponeurosis, it gets hit with biaxial stress. That means it's being pulled lengthwise by the tendon, and it's being stretched sideways as the muscle contracts and bulges out. It's like a trampoline canvas being pulled tight by all the springs while someone is jumping up and down in the middle. It gets stressed in two directions at the exact same time. And check this out. This is the why behind that two-way stretch. Just look at the stiffness here. Lengthwise, the aponeurosis is incredibly stiff, which makes sense. It's designed to transmit force. But sideways, whoa, it is over 100 times less stiff. Now, that's not a flaw. It's a design feature. It's supposed to be flexible sideways so it can stretch and make room for the muscle as it bulges during a contraction. So what this all means is that this unique two-way pull creates this incredibly complex stress environment. It becomes a point of vulnerability that is completely different from a simple pull on a tendon. This is the hotspot for that tiny, hard-to-heal microdamage that just feels like a nagging injury that never, ever goes away. Okay, so we have a unique structure that's under a unique kind of stress. Let's connect all this back to our original question. Why does this matter for that hamstring that just will not seem to heal for good? Well, the proof is right here in the recovery time. Look at this. An isolated muscle injury, a simple strain, might sideline you for, 2 to 3 weeks. But a severe injury that involves the aponeurosis? Wow. The average return to playtime can skyrocket to 88 days. That huge difference shows you just how critical this hidden tissue really is for a full recovery. So, what can you do to protect this unique structure? Well, there's no single magic exercise for it. It's all about supporting the entire system so it can handle that two-way stress. A balanced routine builds strength to support the tissue. A proper warm-up makes it more elastic and ready to stretch. Stretching after a workout helps it stay flexible so it doesn't get brittle. And maybe most importantly, listening to your body gives that complex tissue time to repair itself from that constant biaxial pull. You have to care for the whole interconnected unit. So, we finally pulled back the curtain on the aponeurosis, that hidden player that's not just being pulled like a rope, but stretched like a canvas in two directions at once. So the big question I want to leave you with is this. Now that you know about it, how will you train? And maybe more importantly, how will you recover differently?